So far we've done one example of using the method of partial fractions. We're going to do one more example, so at the end of this video you'll hopefully be even more familiar with how to evaluate an integral using the method of partial fractions. Alright, example 2 says to evaluate the integral of x plus 6 over x cubed minus 4x. Alright, when I look at this to start with, I might think of separating the numerator. First of all, I try u substitution, will not work. I might try separating the numerator, but if I did that, I don't think any good things are going to happen with that. It definitely is not an arc problem at all. So one thing that I do notice is that I can factor the denominator. That is another hint that partial fractions is the way to go. So I'm going to use partial fractions. So if you recall, in step 1 of partial fractions, we factored the denominator. So I'm going to leave the x plus 6 alone, and I'm going to factor the denominator. It would be x. I could factor an x out, and then I'd get x squared minus 4. And then actually I could go one more step on this one because this is going to be x plus 6. X squared minus 4 will also factor. So I'm going to have x plus 2 times x minus 2. Alright, so that was the first step. The second step was to create 3 separate fractions, or however many separate fractions we're going to need. Actually, we're going to create 3 separate fractions because there are 3 factors. So we're going to have, I'm going to put x plus 6 over x times the quantity x plus 2 times x minus 2 actually equals a over x plus b over x plus 2 plus c over x minus 2. All right, step 3 was to set the numerator, well, actually before we set the numerators equal to each other, let's get a common denominator over on that right side. So I'm just going to rewrite the left side just for a minute so we don't forget that it's there. All right, so if I get a common denominator, the common denominator is going to be x plus 2 times x minus 2. The first one I'd have to multiply by the x plus 2 and the x minus 2, so this is going to be a x plus 2, x minus 2, and then plus the second fraction I'd have to multiply by the x and the x minus 2, so this will be bx times x minus 2, and then plus the c would have to be multiplied by the x and the x plus 2, so it will be plus c x and x plus 2. Alright, so we've gotten that common denominator. Our next step is to set the numerators equal to each other. So I will have x plus 6 equals a x plus 2 x minus 2 plus bx times x minus 2 plus cx times x plus 2. And this might look like quite a bit lengthier of a problem, but really it's not too bad. It's not going to be any harder to solve. All right, so we're going to try to find the a, the b, and the c. The first thing that I'm going to do is I'm going to let x equal, I think I'll let it equal 0 to start with because that's what would make the x equal 0. So when I let x equal 0, I need to put the x in everywhere I see an x in the entire equation. So if I put 0 here, I'm going to get 6 equals. All right, on this one, if I put 0 in, I will end up getting 2 times negative 2, so I'll get negative 4a. And then if I put 0 in for this one and 0 in for this one, those just drop out, so I end up getting that 6 equals negative 4a. If I solve that for a, I'll get a is equal to negative 3 halves. All right, let's let x equal negative 2 next. It doesn't really matter which one I do next. So when I let x equal negative 2, I'm going to get 4 equals. When I put negative 2 into this first one, the a drops out. When I put negative 2 into this one, I'll get negative 4 times negative 2. That's going to give me 8b. And then when I put negative 2 into this last one, this will become 0, so the c drops out. So if I solve this for b, I'm going to get that b is equal to 1/2. All right, now I'm going to let x equal 2. And again, notice the way that I pick those x values is what will make the denominator equal 0. And then from here, if I plug 2 in for my x, I'm going to get 8 equals, plugging in 2 for in this first spot, the a will drop out. Plugging in 2 for the second one, the b will drop out. Plugging in 2 for the third one, I'll get 4 times 2, which is 8. So I'll get 8 equals 8c, which means c is going to equal 1. All right, my next to last step is now we're just going to rewrite this problem. I'm going to come right back up into this part and put my a, my b, and my c in. So my a was negative 3 halves, so it's going to be negative 3 halves over x plus b, which is 1 half over x plus 2, and then plus c, which was 1 over x minus 2. And now we've created 3 separate problems. Since all of those are du over u problems, we will end up, this first one is going to be negative 3 halves ln x. This next one will be plus 1 half ln x plus 2, and I forgot my absolute values on that one, and then plus ln x minus 2. We have numbers out front. I'm not allowed to combine these if there are numbers out front, so I'm going to move that to the power spot, and I'm going to move that to the power spot. So this will actually be negative ln x to the 3 halves, and then this will be ln square root of x plus 2, and then this will be plus ln x minus 2. Okay, when I'm combining them into one problem, I am going to, if there's a plus sign in the between, they're going to get to stay on top, and then since there's a minus sign on this one, it belongs on the bottom. So I'm going to have ln absolute value. I'm going to have square root x plus 2 times x minus 2 over x to the 3 halves, and then that whole thing plus c. And that should do it for me. So hopefully now you're even more familiar with using the method of partial fractions to evaluate an integral.